Okay, all right. I think that we can start. So good morning to everyone. Thank you for being here today. This is our first webinar. It is the first of 3 webinars. And today we will understand together how to support the development of circular processes with different value chain, thanks to new technologies and new methodologies. This is the first webinar, but there will be the second one in June and the third one in September. Today, the projects involved are AutoTwin project, Da Capo, DCIM, and the Restore project. So today we will see together the presentation of this project, the domain, their consortium, the main objectives of the project, and the solution that they want to achieve. Some words to introduce Syxis. Syxis is an European innovation hub that connects SMEs, organizations, and research centers to go to innovation. So it helps companies involved in founded research by supporting them with methods, operations, and technologies to develop new strategies, only for circular economy, networking, and digitalization. In AutoTwin, we are involved in the definition and the development of the project software architecture. And we also support the project in the networking and clustering activities like this, thanks to the hyper manufacturing community. So we can start from the AutoTwin project. For every kind of question, you can use comment in a question and answer section. Thank you.
Okay, can I share, right?
Yes.
Okay, so this is. You see my screen? Yes.
Okay. Yes, we see it. Thank you.
Okay, thank you, Alessandra. Just a few words before entering into the details. Okay, so I think this kind of meetings can be very useful for different project clients to develop new technologies, let me say, in the same field, okay? Or can be very boring because we just you know, we use standard presentations of our projects, and then is okay, and then we will meet again in June. Okay, so I'll try to go for the first direction. Okay, and maybe not giving more the details of the project, because we can not so many details about the project, because we can have many other technical meetings if we want. Okay, but let's try to understand, for instance, from the AutoTwin perspective, what do we need, for instance, from other projects similar to AutoTwin, and how can create a critical mass, maybe to do some activities that I don't know, for our consortium we are facing some difficulties. Okay, so let's hope to go forward to the first direction, so something useful for all the projects. Okay, so sorry, Alessandra, how many minutes do we have? 10 minutes, more or less?
10 minutes, yes, more or less, okay. Yes, 10 minutes. Thank you.
Okay. Okay, AutoTwin project. These are just a key number, the main figures of the project. Let me use the laser pointer. There are 13 members, 8 countries. Like other projects in this call, it started last month of 2022. It has a 3 years duration. The total effort is around 7 million euros. And their total EU funding is 6 million euros, because we have 2 partners from Switzerland that is funding with different, let me say, origin of funding. 22 deliverables, 10 milestones, but mainly more important are the results. We defined 7 key exploitable results. We call key because these key exploitable results are grouping other smaller results. But if we put together, we group together these small exploitable results, we create what we call key exploitable results. That is a kind of suite or something. The project is addressing 3 product value chains. In the beginning was batteries for electric vehicles, but in the first year, the company changed the market. So these are batteries for, let me say, energy storage in companies, okay? And then medical devices, sterilization of medical devices inside the hospital. So here we have the healthcare sector, and then the industrial player sector, that is recycling of the plastic. A few words about the consortium. We have, let me say, started from universities and research centers that I'm more familiar. I'm the coordinator of the project. I'm professor in Politecnico in Milano, Department of Manufacturing. Other universities are Koç University in Istanbul, that is more involved in optimization and business models. Technical University of Eindhoven, that is more together with Politecnico involved in creation of the digital twin. And then we have, let me say, IBM, that is a technological partner, but here is participating with a research center in Israel. And then we have technological partners like Ubitech, that is dealing with, let me say, safe exchange of data. Okay. Then we have a core in Greece, even Ubitech is in Greece, and other technological partners are Requirgo, Syxis, TTS, and Innovalia. TTS is here. And then we have the 3 use cases that are Chroma, so sterilization in healthcare in hospital. And then we have Libatian batteries, and then green plastic. I mentioned everybody, I hope. Yes. Okay, objectives of the project. What is working on auto twin mainly? Okay, we have 3 pillars. The data pillar. So we collect the data from the circular value chain, from the actors. So we collect lots that move from actor to actor data when it moves. We collect products that are sold, that are repaired. We collect events, timestamps. So when the product moves, we are collecting the data and we store somewhere. Okay. And then these data are collected, and we use this data to create the models of the digital twins. Here you see a graph. Okay, technically it's a vector net, but it's not necessary to know that it's a vector net. Anyway, this graph is modeling what? Is modeling a part of the value chain, the circular value chain, that can be the recycling plant of green, okay, of plastic, or can be the sterilization center of Chroma in the hospital, or can be here the energy storage of Libatian, or the battery, okay? And so from data, we generate in the most automated way, I'm saying, the model of the digital twin. This model then is transformed into a digital twin, to a simulation model, a software application. And this transformation from data to let me say, a simulation model that is the model of the digital twin is done in the most automated way. So this is the main claim of auto twin. We move from data to digital twin automatically. Why digital twin? Because circular value chains are complex. They must be efficient. They must synchronize the resources, production flow, information flow, and without a digital twin to support making decisions, it's very difficult. And so the rationale is that digital twin, we don't have so many skills to create a digital twin. It's very expensive to maintain a digital twin. And so auto twin is creating from data, is generating digital twin models from data of portions of value chains, okay, or the circular value chains. And then after we have the models of the digital twins and some insights from data, then we can make decisions, and we call green decisions. So we create a concept of green gateway, in which these are decision points that the company, thanks to the digital twin, can decide about a new refurbishment, a new repair, or I decide to recycle. Okay, so these are the three pillars. And after we implemented the decision, we analyze the data and we see if the company is following the decision, and then again and again and again. Okay, this is the main objective. Now, Alessandra gave us a slide with a dedicated to new business model towards sustainability. Frankly speaking, we are not proposing no new business model in auto twin. Okay, this should be clear. Okay, we are not aiming to propose new business model. Okay, the project aims to improve the efficiency of circular value chains through digital twins that are always updated thanks to the loop that I showed before, from data to model to decision, and again, data, model, decision, and so on. And so the rationale is that we will have a low cost. We can use not so high skills for creating and maintaining these digital twins that will support the actors of circular value chains. So there will be no new business models. I don't know the other projects, so I'm curious about this, if we can learn. And what do we expect? Now, what auto twin is expecting from this cluster? So, frankly speaking, we have three use cases. But in our use cases, we have mainly only one actor of the circular value chain. Because if you take the recycling, okay, we don't have the textile companies that are collecting the textiles and then sending to our company, Green, that is taking this material and then creating, recycling the material. We don't have all the actors. So we realized that in all the three use cases, we only have one actor of the circular value chain. And so this is a little bit, we cannot show that our digital twin is taking into account several actors in the same simulation. Okay, now we can only generate a digital twin from the events that we collect, from the data that we collect from one actor. Okay, so it would be nice if one of your use cases is involving more than one actor in the circular value chain, and you have information and details of more than one actor. And then we can try to understand if our solution can fit with your use case. We cannot customize the solutions that we are developing for another use case, of course. But we could make an analysis on your use case if our technologies may fit or not. And for us, this would be useful because we can try to validate conceptually our results outside auto twin. Another thing that I put here, that it will be also in the next slide. We want to have an outreach impact, okay, and on the project. I don't know the situations in your projects, but we understood that we need a critical mass to do this. Okay, with only our consortium, it's very difficult to have this outreach impact. And so, second point of what do we expect? It would be nice to have synergies and maybe transfer similar concepts, okay, creating joint events, so we can leverage the cluster. Oh, sorry. And then Alessandra gave us this slide about issues and countermeasures. Just look at the first point. Now we are facing just the standard issues that every power project has in the last year. We are closing in November. We will not postpone the end of the project. There is no need, but we have to rush. Okay, so I don't bother with the details of all the technical issues that we have. We have many, I think, like also your project, but we are managing. Okay, maybe just I point out these 2 points. The main issue is again the fighting between generalization of the solutions versus customization. Okay, and how much we should customize the solution or how much we should push about the generalization. Okay, and then the impact on industries, as I said before, I'd like to leverage this cluster to reach a critical mass and then to have a higher impact outside the consortium. That is not easy. I think that's all from my side. Of course, we are available to provide many technical details, but I think this is not the place. But invite us when you want to provide more details, of course. I know I was too on the surface, but I think it's better to discuss about the added value of this cluster.
Thank you, Andrea. Thank you. So we can go on with the second project, that is Da Capo. Please, Rola.
Oh, maybe if there are questions.
Or maybe we can have, yes, a question at the end of the...
At the end?
Yes.
Okay.
Thank you.
Hello. Hello, Alessandra. Hello, everyone. Can I share my screen for the presentation? Can you all see the screen?
Yes, thank you.
Okay.
Yes.
Okay. So, good morning, everyone. Thank you, Syxis. Thank you, Auto-Twin, for inviting us in this event. And thanks all the participants as well. Now, if you can see my screen, I'll start. Is everything okay? Because I cannot see. Okay. All right. So let's start. I am Rula Murmuri. I am the Da Capo project manager in a Core Innovation Center. For those who don't know us, Core Innovation Center is, of course, a partner in Auto-Twin, and it's also a partner in Da Capo. It's a non-profit research organization that is providing industrial research and development and cutting-edge Industry 4.0 solutions. Now, I'm here to present Da Capo, which stands for Digital Assets and Tools for Circular Value Chains and Manufacturing Products. Da Capo is a type of, it's a Horizon Research and Innovation Action. It's managed by Health and Digital Executive Agency with a duration of 42 months. It started in the 1st of January 2022, and it's set to finish at the end of June 2026. So we have almost a year from now. So, few words about the Da Capo Consortium. The Capo project is coordinated by IMEN. IMEN is a non-profit research and technology organization based in Spain, and altogether is comprised of 15 partners from 10 European countries. It exhibits a great mix of complementary expertise. We have 8 research and technology organizations, 4 large companies, 2 SMEs, and 1 European association. And as you can see also on the map, it also demonstrates a wide geographical coverage. Now, so where are we? Where is the set? What are the challenges that we are trying to address? So the Da Capo project addresses the current high dependency on imported and critical raw materials in supporting the resilience of EU industry, the need for improving raw materials usage efficiency along industrial value chains, and of course, enhancing the application of circular economy principles and strategies in line with EC Green Deal Action Plan and the 2020 Circular Economy Action Plan. And what is the vision and our mission? The project aims at defining a new set of human-centric digital tools and services for improving the adoption of circular economy strategies along both manufacturing value chains and product life cycle. These digital tools and services focus on the creation of new digital assets, AI-based systems, and the application of process and product digital twins, which will push towards a new paradigm of digitally enabled EU industrial sustainability and resilience. So we are aiming at stepping away and switching from the traditional models, business models, towards more circular approaches. Okay. The specific objectives, it's to establish an agile methodology for the efficient implementation of circular economy strategies in the EU manufacturing value chains, to implement a digital architecture and a data-driven pipeline enabling new sustainable and circular business models, to develop AI-based tools and digital twins for the new circular product life cycles, and lastly, to facilitate the uptake of the digital tools and circular business models by industry and society. And we do this following an approach which is holistic and human-centric, and can briefly encapsulate it in 3 key pillars and aspects. First, as I mentioned before, is the development of the agile methodology, which includes the definition of circular business models and material flows repository that comes together with agile and accurate sustainability and circularity indicators that will move and work towards the consolidation of circular economy strategies in manufacturing value chains. Further, we have the development of a robust digital infrastructure, which includes a digital platform that will serve as the virtual environment to deploy and provide the Da Capo digital tools, a modular digital thread concept. Yes, sorry?
Sorry, Lola. Your slides are not moving yet.
Yes.
If you can.
The usual.
Yes. Thank you. Thank you, Diana, also.
Okay. Give me a sec. This is
we are now in the
typical.
objectives.
Okay. Okay.
Okay, now we are, yes, in the Da Capo approach.
Okay.
Digital infrastructure.
All right.
All right, thank you.
So I will not reiterate. So let's stick to the digital infrastructure, as I said, which has the digital platform, the modular digital thread concept as an end-to-end digital pipeline, and the digital product passport for digital representation. And lastly, this digital infrastructure goes hand in hand with the development of AI-based tools and digital twins, which include realistic digital twins for product and process digital twins, the circular economy decision support system as the key knowledge backbone, and then product setting management and eco-design approaches, sustainable manufacturing strategies at shop floor level, for early detection and also advanced diagnostic tools and improved predictive maintenance strategies. Alessandra, is everything okay? Okay, all right. So very quickly, some words about the use cases of the project.
Yes, sorry, we are again in the digital infrastructure slide.
Okay. I think it's a question of...
Yes, we are in the use case now.
I think there is a delay of when I... Okay. So I'm sorry about that. I don't know how to...
Don't worry.
I don't know how to fix it. Okay, the three use cases that we are going to test the solution and what the project's proposition is first in GKN Aerospace. GKN supplies advanced aerospace systems, components, and technologies. It designs, develops, and manufactures, assembles, and maintains engine and rocket components for both commercial and military applications. So the use case that will be tested is to extend the sustainable manufacturing and repairability approaches for aeronautic value chains. So the emphasis is on manufacturing engineering, and the enabled circular economy strategies is to reduce, to remanufacture, and repair refurbish. The second use case of the project will be tested with Fairphone, which is the ICT and consumer electronics company. It actually provides smartphones, sustainable smartphones, alternative to what is in the market, and addresses the make, use, dispose trend by creating modular smartphones that are durable and easy to repair. The emphasis and... Sorry?
The slide is not...
Okay.
Thank you.
Okay.
Perfect.
Is that better?
Yes.
Fairphone, yes.
Okay, so with Fairphone, the emphasis is on eco-design, diagnosis, and maintenance for modular mobile phones. Again, the product life cycle stages addresses design, engineering, user face, and end of life. And lastly is Pesmel, which is a warehouse company located in Finland. Pesmel delivers solutions that improve material flows and logistics at different types of manufacturing facilities. Their focus is on serving customers around the world in the pulp and paper, metal, and tire manufacturing industries. And here, the use case will be for the R cycles and material flows for warehouse design, construction, and operation. Again, the emphasis is on better material, optimizing material flows, design, engineering, and user face. It's the product life cycles addressed. Okay, last but not least, the capo proposition will also be tested and validated in the didactic factories network, which is an open, accessible pilot facilities hosted at the research and training organization participating in the project. This will be coupled with a complete replicability boosting strategy, focusing on lower market acceptance barriers through supplementary actions. And this is done in order to move further than addressing the technical challenges that the circular economy strategies adoption imposes, but also to face workforce skill shortage regarding the adoption of new advanced digital tools and services, and also to tackle lack of awareness, trustworthiness, and risk aversion of end users to new digital technologies adoption. Now, in a nutshell, this is what we are trying to do. Maybe the slideshow was not so helpful. I apologize. But this is a first kind of bird's eye view of the project. I hope you get a bit of a better understanding of what we do. There are 2 more webinars, as Alessandra said in the beginning, that we're going to follow. In the next one, we are going to present the GKN pilot, which I think will be very insightful and interesting in what we are trying to do with these webinars. And in the last webinar, we're going to also dig deeper into the lessons learned and the issues and the, also new opportunities, the overall impact, and how we can also mold this into maybe future ideas and proposals. So thank you. That's all from my side. Thanks.
Thank you. Thank you very much. Yes, of course, today is the first webinar, so we have to know each other and understand what are our projects. So we can go on with the third project, that is DICIM.
Yeah. Okay, give me a second. I will share the presentation.
Yes, thank you.
So, do you see the slides?
Yes, we see them. Thank you.
Great. So I'm here on behalf of DICIM projects. DICIM stands for Digitalized Value Management for Unlocking the Potential of the Circular Manufacturing Systems with Integrated Digital Solutions, which is very long and complicated title. So I will try to make the title more understandable for everybody during the presentation. Okay, the slides are not moving and I'm not sure why. Oh. So I will try to reshare the presentation because the slides are not moving.
Okay.
I'm not sure why. Now I guess you see the slides moving. Yes, the technology. So, you know, 4 different people using the same system and they have 4 different problems with it. So we started our project in January 1st in 2023. We are 1.5 years before the end of the project. So we are at the stage of developing the prototypes and technological solutions. The main purpose of our project is to help companies that are going through a circular manufacturing transition. So they want to not improve, but change the philosophy in the company from linear manufacturing systems into circular manufacturing systems. We are helping the demonstrators, and I see that I forgot to include them, the most important ones. So the demonstrators we have is Gorenje, which is part of Hisense Group, located in Slovenia, and we are working with their washing machine division. The next demonstrator is Lexmark. Recently they were bought by another company, but still they use Lexmark name, but maybe it will change soon. But what's most important is that we are helping them with their printing business models. The third partner is Arçelik Beko and their division of refrigerators. And the last partner is Sieco, which is a logistics or circular logistics provider stationed in Germany, but their operations are worldwide and they are in the sector of automotive. Now, we have 4 university partners. We call them knowledge partners, which is Masaryk University, from where I am. We are stationed in Brno, Czechia. Then the next university is KTH from Stockholm in Sweden. Another partner is Technische Universität Chemnitz in Germany, and the last university partner is University of Ljubljana from Slovenia. For development of some technologies, we have 3 technological partners. Iris and Idene are research and technology companies from Spain, and Significant is a software company from Sweden. The same partner is Crowd Helix, and we have associate partners, which is APRA and European Remanufacturing Council. So what we want to do is, as I said, support transformation from the typical linear manufacturing system to circular manufacturing ones. So that the companies are able to reuse the value they put into their products and deal with the returned products either through take back or buyback process. Specifically, we will employ, or not will, because we are already working on that. So we are employing artificial intelligence and machine learning algorithms that should support decision making about reusing value in returned products. In detail, this means that if Lexmark, for example, gets back 100 printers from a business partner they operated there, they need to make decision what to do with the printer. So are they able to use the printers at a different business partner, or do they need to refurbish them because they are approaching end of life, or they need to they are hard or expensive to refurbish, so they will salvage them for spare parts. And this is very hard to do with just reading the condition of all 100 printers. They don't, of course, have 100 printers. They have several hundred or thousand printers that they need to decide what to do each year. So with artificial intelligence that will use the historical data and condition monitoring data about the printers, we are developing decision-making algorithms that will basically help Lexmark to assess the value or the value of the printers, and then make a much better informed decision that will help them to lower costs. Another part of circular manufacturing systems we are focusing on is inspection and dismantling process. So I guess most of you understand what the difference between circular manufacturing systems and linear manufacturing systems are, but in general, in linear manufacturing systems, you manufacture most of the things in a big batches, so you are doing the same thing over and over and over. However, if you get return products, you get products with different sizes, different dimensions, different models. And when you need to inspect them and assess their condition or dismantle them, you cannot do it automatically, not even semi-automatically at that time. So the workers or the operators, they need some heavy assistance to be productive. From that reason, we are developing artificial or augmented reality for sorting process and dismantling, and image processing for appliance testing. And another part of what we are doing is improve condition monitoring through IoT, meaning that the first and second point, the artificial intelligence and inspection dismantling process is heavily based on data from or originating from use of the technologies. Therefore, the more relevant data the appliance will produce and store during the phase or the use phase, the better for the artificial intelligence algorithms and support for inspection and dismantling will work better. And also, as the last part, we want to develop a platform that will make easier to take or buy back a product, and at the same time to offer spare parts to very wide markets, not only to B2B partners, but also to B2C partners. Regarding the business models, we don't directly create new business models. However, the developed solutions can significantly strengthen current business models. That's one thing. Or that it could in the future open space for new business models, because if the companies will be able to increase their inspection and dismantling or refurbishment processes, they can introduce new business models. For example, pay-per-use business models. Gorenje tried to play with a pay-per-wash business model in the past. And for deservitization or pay-per-use business models, it's crucial that the company has a good process and operations focused on spare parts and refurbishment of the appliances. Now, this is how we do it. So at start in the first year, we did a very thorough requirement specifications for all the developments, and we assessed the feasibility of the technology. And currently we are in the stage that we are developing the open access product information management platform and development of the digital solutions. Soon we will be approaching to integrate the solutions into actual processes, so we will start with demonstration activities. At the same time, we are trying to assess the socio-economic and environmental performance of our developments, and also we need to assure that the training and adoption of the technologies will go smoothly. And management and dissemination, of course, is a standard thing in the projects. What we are thinking or are a bit struggling with are technology implementation barriers and challenges, because even though we did a very thorough specification during the implementation and development, we found, or well, mainly the technological partners found lots of barriers and challenges that were not expected, because what we are usually or what we are doing in these projects are things that we cannot get inspiration from elsewhere. So we are pioneering some of these solutions, and it brings lots of challenges that we didn't expect. We will have to brace for adoption and training of the future users. So that will be another big challenge and an issue we will be dealing, and any knowledge sharing in this area would be helpful for us. And of course, which is the typical problem with scaling from prototypes and single use cases to mass use, right? What works in kind of a laboratory environment is not as easy to implement in the main or primary processes in the company. So these are topics that we are interested in maybe future webinars. So AI and ML in circular processes. augmented reality and image processing, and in general, remanufacturing and circular manufacturing operations. And that's it from my side. Questions now or later, I don't care. But what I care is that I will happily answer them.
Yes, thank you. Thank you. Yes, I think that we can go on with the last project and then we can have some moments to discuss if there is some question or something else to see. Thank you. So please go on.
So I believe it's my turn now. Yes. Yeah. I hope you can all see my screen.
Yes.
Yeah.
I think that it's the last slide now.
Yeah, you're right. So I'm
Thank
quick.
you.
Yeah, just a second. Sorry. Wait. Okay, so now I think I will share this correctly. Yeah. Okay.
Perfect. Thank you.
So I will be quick because we don't have a lot of time, and if there are questions, then. So my name is Diana Rodrigues. I am a project manager at EWF. EWF is the European Welding Federation for Joining and Cutting, and I'm here to present Restore. So yeah. So Restore is also part of the Made in Europe partnership. I think in comparison with the projects that were presented so far, we are quite new. We just started last year, so in 2024. Our partnership is, we are in total 20 partners. The coordinator is EWF, so I'm the coordinator of Restore, and we have partners in the UK, France, Sweden, and Italy. So our use case partners, the industry partners are Stellantis, Lucchini Rail, and also Navtec, and Welding Alloys. And Doffersen, which is in Sweden. And we have like associated technology partners that are, for instance, Fraunhofer, IRIS, Flowfis, and a knowledge partner, as well as Cranfield University. And then we have like the business model and innovation partners, that is Parida Consulting, as well as EIT Manufacturing. Yeah, so basically the project addresses remanufacturing challenges and is focused in like 3 different pillars: materials, processes, and digital tools. So the idea is to address the challenges of remanufacturing implementation by developing advanced cladding technologies, zero waste materials, meaning consumables with recycled content, and a comprehensive digital platform. So our first objective is to create the sustainable cladding processes and consumables, then to develop digital tools for increased automation. So the first specific objective is more related to the materials side. The second one with the processes, and the third one to develop the Restore platform for remanufacturing is aligned with the vertical of the digital tools. Across all this, we want to scale business model innovation for remanufacturing and, of course, demonstrate the use cases. So this is our project timeline. We have started last year, January 2024, we had a kickoff. We have already finished work package 1 that kind of set the scene for the coming work packages. So we did a state-of-the-art analysis, defined some remanufacturability KPIs and specifications. Now we are finishing the sustainable process and consumables, and this is led by Grenfell University. And at the same time, we are developing the digital tools for sustainable remanufacturing with all the process models for automation. And this, the partner Eurobase in Sweden is an important stakeholder developing this work. We will then start with a platform and then advance to the use cases. And the use cases are four: so rail industry, steel industry, naval industry, and automotive. So the first one is a remanufacturing of a rail axle, that is a Lucchini rail. Then we have the second use case of remanufacturing the steel rollers, that is Dalfershan, and then the ship propellers, which is led by Navtech, and the remanufacturing of automotive components that is led by Stellantis. So regarding the digital tools, we want to introduce sustainable by design remanufacturing processes and have this supporting tools for the digitalization of the remanufacturing ecosystem and value chain. So this is aligned with the automation of the specific processes. I have a video.
In a world focused on sustainability, moving towards a circular economy is essential. Instead of discarding old products, imagine if we could give them a new life, reduce waste, and create valuable jobs in the process. That's where remanufacturing comes in. However, building a sustainable remanufacturing system isn't easy. Companies face challenges in adapting processes, rethinking designs, and creating new business models that support sustainability. Restore is on a mission to overcome these challenges. By combining innovative technology with digital tools, the project aims to create zero-waste remanufacturing solutions that are both efficient and environmentally friendly. Restore introduces new processes and digital tools designed to make remanufacturing easier and more effective. Hybrid manufacturing process. By combining cutting-edge laser and plasma technologies, Restore enhances efficiency for large-scale applications. Zero-waste materials. Using recycled materials to create new wire feedstock, Restore reduces waste and costs. Digital tools. From automation to decision support, the Restore platform offers a suite of tools to streamline remanufacturing. At the core of the project is the Restore Digital Platform, a powerful tool for stakeholders. It includes process automation to streamline operations, simulation tools for optimized production, decision support frameworks for data-driven choices, eco-design principles for sustainability, a blockchain-enabled digital passport to track and trace products, a digital marketplace to connect remanufacturers and buyers. With Restore, the remanufacturing industry can operate more sustainably. By reducing waste, saving energy, and reusing materials, Restore helps build a cleaner, greener future for all. Interested in learning more about Restore? Get to know our project partners. Together, we will build a sustainable remanufacturing future. Restore is co-funded by the European Union, supporting a circular, resource-efficient future. In a world...
Yes, so I think that it encapsulates a lot of what I have been talking about. And now our expectation is to explore new developments and potential collaboration with other ecosystem stakeholders, and as well networking with experts across Europe. Also, we have an ongoing citizen engagement initiative that is led by IT Manufacturing, and it will be really interesting to get to know your stance on remanufacturing and get to know your challenges. And that's it. Thank you. I hope I managed.
Thank you very much. Thank you. Yes, so I think that they are all very interesting projects. I don't know if we have some question about maybe if we can have some synergies or common points, or if you heard some situation that can be similar to your project or not, and why. I don't know, maybe from Auto Twin project, there is some points.
Well, I believe for us, as I stated, for instance, it would be interesting to have the collaboration of stakeholders that are involved in remanufacturing to maybe participate in some surveys that we have. So this is the thing, because we still haven't really entered the demonstration phase, but we are doing a lot of needs analysis also for training in remanufacturing, and if so, for us it would be valuable to have this input from players in these ecosystems. But yeah, from our side.
Thank you.
Maybe an example from the presentation of Michael, but there are common points in other projects. For instance, where in that project, you are working on AI solutions, right? For understanding what to do with the product. Okay. For instance, in Auto Twin, we are not providing these AI solutions. Okay. We are more at system level. At product level, we are developing a digital twin of the energy storage. Okay. But then we don't have an AI tool to do some analysis. Okay. For instance, could be maybe useful for the project that Michael presented to analyze our energy storage case, for instance. And for Auto Twin could be useful to see the I think you are the dismantling factory, something like this, right? You say it's not a mass production. We have to disassembly, so we have to coordinate the resources. And so to check if our digital twin could be generated automatically also for that situation could be useful for us. And this is just an example of what we can do together, right? At the technical level.
Yeah. Can I have what do you meant to automatically generate the digital twin? I didn't kind of understood what you meant by that. So if you can give me an example or something to picture.
Yeah, for instance, if we have an history of data of the products that enter into a station, the type of product, and then when leaves the station, and then goes to another station maybe or something. If we have this history for each product ID, okay, then we can understand the flow, the resources that were used to let me say process the flow, the items, and then from those data, our algorithms try to build a discrete event simulation model. That can be used for scheduling, for routing, for for controlling the flows.
Yep, thanks.
Welcome. We don't in Auto Twin, we don't have remanufacturing companies with remanufacturing problems because we have plastic recycling and cannot be considered remanufacturing. I think you need something like metal products or something like this. But maybe the couple, or Michael, like that. So maybe Alessandra, why I don't know if it is possible to collect in some ways, because now we are online, okay?
Yes.
But then we have to think about this. I don't know how you can collect from us, I don't know, this expectation, this.
Yes,
This.
we can try to do this maybe in another moment. I can give you some slides and you can put them all these points, and then we can discuss these points in the next webinar also if you want.
Yes, yes.
Yeah, maybe what we can do is that each project could try to send the ideas of some synergy points or these things, and then you can collect them together and we can recheck.
Yes.
Yes, it's a good idea. Thank you. Yes. All right.
Now
perfect.
I still have some question to, I think it's Diana from Restore Project.
Yeah.
Is it? Yeah. How do you approach the digital support for the remanufacturing? Because from my knowledge, most of the companies they have ERP and some system either in ERP or connected to ERP for manufacturing support, planning and manufacturing. But if I understood correctly, you are trying to develop something that would digitally supported the processes in remanufacturing. So can you tell me more about that?
Well, I can tell you the level I understand, okay? Not going into too much technical detail on the digital solution itself. Well, so what you are talking about, the things that are already in place. So this the Restore platform, it's being developed by Technovative Solutions. So it has been an ongoing work that they have also from other projects, and they are developing. So basically, it's a platform that has. So it's standalone and probably will be like a web service or something like that. It also has a marketplace where so it connects the stakeholders that have pieces to remanufacture with ones that do the remanufacturing of the pieces. And for that, there's also like the business services that offer like all the like topographical analysis and the simulations and so on. So it's more like a marketplace. And then it has this marketplace dimension, and it also has it's coupled with a blockchain API that inserts the information of the remanufacturing in the digital product passport. So this is not embedded in any ERP, I think probably in the future, but this is just still at the concept level, I would say. So we have these different use cases, right? And we will test this digital platform like this, the Restore platform, using the use cases and everything. So we are not like putting this just yet into a factory or so, where it's not there yet. Also because even for the parts that need to be remanufacturing, so remanufacturing is many different steps. So you need to like take the piece, need to analyze this to see the defects, need to select the materials, need to have the design, the new design to see which. So there is a lot of decisions in between, right? So it's and the platform is enabler, a facilitator for all of this, but it's still conceptual and still being like TRL is probably 7, 8 at the end of the project. Yeah. I hope I answered your question.
Yeah. I got some more information. Because of course we always think what to do next after this project, how to push it and develop some things further. And one thing could be a kind of a IT support at the remanufacturing process level. So one thing is to connect the supply and demand for spare parts or refurbishment parts, etc., etc. But the other thing is how the companies that are actually doing remanufacturing should digitally support and maybe at least semi-automate the actual operations, because if this will not work productively, then there are not many cases for remanufacturing in the end, right? And there is a really big mismatch, not only about like other things, but there is a big mismatch, like how much software supports the linear manufacturing, because it's almost completely, or could be almost completely automated, and how much the remanufacturing process supports it, because usually the companies have something like internal solution that is not very ideal and is very, very simple in that regard. So my thoughts went into that direction. But if I understood correctly, you are more focusing on connection to DPP and kind of a matching or clearing the supply and demand.
Well, I mean, not only because, so we have also Fraunhofer that is very much invested in developing the VMAP standards, and they are using use cases of Restore. So basically, and this is a very big step towards what you are describing. But at this moment, so in order to have automation of the remanufacturing tools, you need like the systems need to understand like the cladding processes digitally. So there needs to be like a standard for that of the materials and how to remanufacture the materials and how like how the machine understands the processes that are developed. And this is being developed as well. So it's the materials, the processes, and then the platform. But this is still, well, it's not in the beginning because some work has been done, but it's. I think we are still a bit far from the scenario that you are describing in terms of remanufacturing. But the work is being developed. So maybe it would be interesting to have a presentation on Fraunhofer regarding the VMAP standards in that regard. But yeah.
So you need highly skilled workers for this type of manufacturing.
Yeah, I would say so. Yeah.
Yeah, that analyze the part, analyze the, they know the metal, the material, and then they decide the process, right?
Yeah, or someone that is in the design of these digital tools, right, and knows how to interact with them and to,
But the main goal is for the companies to make this as less dependent on the very skilled workers as possible, because then it's costly, and scaling up the operations is very complicated because there is limited number of the professional or skilled workers that really understand that, and they are expensive and there is not enough of them. So therefore the remanufacturing process is then very costly and doesn't make much sense for many companies to do it because it will not bring them enough value. So anything that can help with not automation, but at least some kind of a semi-automation or these things is very valuable, because it really like drives the cost of remanufacturing down, and that's one of the main goals to do. Okay. So I think I will discuss with people from my consortium, at least, or part of them. And maybe we can follow up on that, and maybe trying to find if we will think about something that we can maybe do together in the future.
Yeah,
sure. Just I have a last technical question to everybody, if it's possible. In your use cases, the companies, do they have advanced information about the products that are coming back for remanufacturing, for dismantling? Do they have some information from the network?
Yes and no. It's for example, if I say Gorenje, for some appliances they have the information because they were connected through smart features. So somebody just connect them to internet, and they have data about what the washing machines did, but not all of them. So they know what is coming back, but for some, they have some data about in what condition the appliances has. With some, they have no information. So what they are trying to do in this regard is, because they have a durability laboratory where they test the new models, how durable they are. So they have lots of data from them. And the AI algorithms are basically trying to do this. So they take the data from the testing and they try to extrapolate basically what the appliance could, or in which condition the appliance could be, from the very limited or almost no data they have. So in the worst case scenario, they know when the washing machines was purchased, probably they know when it was delivered to the customer, and that's it. They know when it was taken back. Of course, they can have some inspection to connect the PCB and have some stored information there, but then they don't know what is coming there in it. With Lexmark, for example, because they are in pay-per-page business, so most of their printers, or not most, but some of the printers that are taken or bought back, were connected for 100% of time of their printing job. So they have very detailed information about the condition. So some companies have data, some of them could or will have, because in the future more and more appliances will be connected to Internet of Things. So that's basically one of the important things for that. So
yeah, in the case of Restore, we have very few data history on. Sometimes it's just like maintenance sheets. In case of the steel, the rail parts, for the steel rollers, most of the time there is not much. Yeah, so it's there is not, and that's why it's necessary also like to scan the PCs and take the data and do all the analysis before the remanufacturing process starts. Yeah.
Okay, good. Thank you. We have many things to discuss here. Okay, Alessandro, I don't know if you can gather the information, and maybe probably if it is needed to have, I don't know, even bilateral meetings to.
Yes, of course.
Because otherwise June can be too long, too late. I don't know, but small meetings, bilateral, just to understand something more, clarification. Okay.
Yes. We can write down all the expectation of all the project and every synergy that we could understand together, and then we can organize the meeting to discuss all these things. Obviously.
Okay.
Absolutely. Yes.
Thank you, everybody.
Thank you very much.
Thank you, everyone. Goodbye.
Thank you. Bye bye.
Thank you.
Bye-bye.
Thank you.
Bye-bye.
take care. Have a nice day.
Have a nice day too.